This video goes over examples of periodic functions. So here we do have a periodic function shown, and the first thing that we're asked to figure out is the period of the function. So that is one whole revolution, so up, back through the middle, down, and then back to our starting point. Our period is that horizontal length of one cycle. In this case, it is 4. Our maximum value is right up here at 10. Our minimum value is down here at 3. Oh, not 3, but 2, all the way down. Our amplitude is going to be the height of the function. So that is from our axis of the curve, which goes through the midline of the function. And our amplitude is our distance either up to the maximum or down to the minimum. In this case, our amplitude is 4. If we don't have a graph, we can always find it by doing the maximum, take away the minimum, and then dividing by 2. So we've got 8. 10 minus 2, which is 8, divided by 2, which also gives us 4. Good thing to remember if you are not given a graph. Next, we're asked to determine the value of the function at f equals 2. So I'm going to go over to x equals 2. We'll do that in red. And then I'm going to go all the way up till right here. Nice little arrow there. My function value there is 5. And then for e, I'm looking for what values of x does f at x equal 5. So that means that I'm going to look really at a horizontal line of y equals 5 all the way across here, because what I see is that there are lots of different values. So it happens at x equals 2, but it also happens at x equals 4, at x equals 6, and then at x equals 8. In order to figure out the value of f at 33, I need to figure out how many periods have gone past in order to figure out at which point of the cycle. So I've got quarters here. So I've got my first quarter here, second quarter here at x equals 1, f at 1 equals 10, back down to 6, down to 2, and then back up at 6. So what I'm going to do is 33 divided by 4. 4 is the length of my period. This is going to give me 8.25. So what that means is it's 8 cycles in, and then 1/4 of the way into the 9th cycle. Cycle. So I know that f at 1 equals 10, and that is 1/4 of the way into my cycle. So that means that f at 33 must equal f at 1, has to equal 10. This really only works because I'm starting at 0. If it doesn't, it's a little bit trickier to make it work, but it does work out in this case. So let's do an example of a Ferris wheel problem. The period of the function is going to be through one whole revolution. So starting from here, my initial value, I'm going to go all the way up and back down, and that is the length of one cycle. Okay, so I've got 8 seconds. Okay, I should add on here, this is my time in seconds, and what it represents is one revolution of the Ferris wheel. The equation of my axis is going to be the equation of the horizontal line that goes through the midpoint of my graph. In this case, it is y equals 4. And then the amplitude is the distance either from that axis all the way up to the peak, or from that axis all the way down to the minimum. So then what I have as my axis is y equals 4, which means I can see from my graph that my amplitude is going to be 3 meters. Okay. The next thing that I'm going to identify is when is Trevor at the top of the Ferris wheel. So Trevor is at the top here, here, and here. So at 4, 12, and 20 seconds. And then what is the diameter of the Ferris wheel? Now this is kind of tricky because it's going to require us to think about what our graph means. The midpoint that we have right here, our amplitude really represents the radius of the Ferris wheel. So because our graph is going, or because the wheel is going to rotate around that pivot point in the center, our diameter of the Ferris wheel is going to be 6 meters.